Hi, I'm JJ Biel-Goebel. I'm an engineer who's worked on aircraft and some ground control vehicles and robots, and now I'm working on big data. And I have a project here that a friend of mine and I have been working on, and we want to see if we can't take it to the next level and see if the Kickstarter community can help us with that. So we're looking to build a robot called FOD BOT I. And FOD BOT I is pretty much going to be a Roomba on steroids. That's OSHA approved, so we're going to potentially actually have to help OSHA create what an approved autonomous robot in the work environment actually means. On steroids, that's capable of operating 24/7 and being a lot more complex in its map creation, its route creation, and I'll say dealing with the production work environment where there's workers interacting with robots. There's expensive equipment around. It's a very dynamic environment. There's other vehicles, making sure that the robot can get its job done while maintaining safety and zero damage to other items. So what is FOD? FOD has two definitions. It's foreign object debris and foreign object damage. And it's any time you've got something small that can get stuck or be stuck or can be ingested or can cause a machine not to work well. It's things like sawdust, metal chips, tools, drill bits, plastic, rags, garbage, pieces of paper, anything that could get stuck someplace. Fasteners are another good one. Zip ties, anything that can get stuck someplace where it could cause damage or cause the machine not to work properly. And this is usually a big problem for big businesses, so that are creating big machines. So aircraft, cars, tractor trailers, trucks, any place where it's a clean environment and you want to make sure that the only things going into the machine are the things that are planned to be there. Now, if you want to think of cost, this is about just aviation alone. It's about $13 billion a year in costs. And also, if you want to count the indirect cost, it could be 10 times that number. It also is a safety thing. If it gets caught in the wrong place in an aircraft, the fuel line, or if it's on a critical shaft, it could kill people, and it has in the past. So this is what FOD is, and so there's a lot of emphasis being put into preventing it. And I'll tell you a little bit about what some of the companies do in just a second. So because it's such a big issue, they'll ask employees to clean at the beginning of shift when they have breaks. At the end of their shift, they'll pay cleaning crews to come in. They'll do morning FOD walks. They'll do a lot of things to make sure that the area, whether it be the ramp, the production facility, the production floor, the hangars, the actual runway, are clear of FOD. And it's an expensive activity. So if you just pay your 500 shop employees, a tenth of an hour to go clean up at the end of their shift, that's like $2.1 million for that company. Or you could pay for cleaning services, roughly 13 cents a square foot. So that's 1.3 million. And that doesn't include any of the security issues or the medical liability you take on when you have employees doing that labor in and around expensive vehicles and machines. So here's an example of a robot that's made to clean offices and hospitals. So it's got some of the features that we're looking for. It's just not optimized for the production environment, as well as the dynamic nature of the production environment. So this follows a specific path. It has some of the blinking lights that we need. It has some of the speakers that are making those annoying beeps. And it has some of the obstacle avoidance, but it doesn't really deal with that dynamic, highly dynamic environment as well. So FODBot is looking to add that capability, all the same things that you would find on a Roomba or this vacuum, the IntelliBot. It's that, am I hitting something? Am I at the edge of a surface? Is there something in my path that I need to avoid? All those things will be part of this robot. The additions will be the ability to create a map of your environment, create a smart schedule for how to, I'll say, break that environment up, and also create smart routes for how to complete that schedule. So if I need to clean a 200,000 square foot space, I'm going to first create that map of that space and then break it down into chunks and then figure out how I'm going to clean that space. And then also make sure that it's completely safe around people, other vehicles, forklifts, things that might not see it. Make sure that it can stop and avoid contact, also that it doesn't contact any of the machines or the tools that it's working around. so that no damage takes place to people or the company's capital that it's invested. So why the FOD bot? Well, you could do it with people, and it's being done with people, but it could definitely be improved upon or added to, augmented. So if you're looking at just a single employee that's made to do cleaning, so they're not the production employee, you're looking at least 30,000 plus a year. So that's about 120,000 over the 4 years or 5 years. Whereas if you look at a FOD bot, it might be $40,000 investment in the first year, but then a $10,000 maintenance and parts investment over the next 4 years. You're going to make out. Plus, you reduce liability medically as well as if it's in a secure environment. Also, the FOD bot is attractive because it hits a lot of different production facilities. Now, this is made for indoors, so it's, you know, if you're making trucks, if you're making farm equipment, if you're making construction equipment, aviation is a big one, or automotive. All these types of companies have a clean environment and need to keep it clean, so they invest a lot of money in making that happen. This might be a way for them to get that same level of cleanliness or possibly a greater level of cleanliness with a lot lower cost and a lot less liability. So the project is really built around taking the current prototype that we have that we've made out of some small sensors and taking it up the next level. So fabrication of a full-size chassis, a charging station. Now this is something we haven't prototyped yet, but it's the ability for the robot to potentially come back and do a quick charge, or to actually drop off one battery segment and go pick up another battery segment so that the actual, I'll say, cleaning part of the robot can just operate 24/7. Integrate of off-the-shelf components. So we've been lucky enough to mostly use off-the-shelf components. We want to try to step that up when we go to the next level and hopefully not have to make anything. Programming the mapping software. So this is something we haven't been able to do with our current prototype because we don't have the LiDAR sensor. So this Kickstarter is actually going to allow us to purchase the sensor suite that we're going to need to do that mapping and start to build that software. And then also the next step is also to integrate the vacuuming pattern and creating that schedule and automatic route software, which we've started, but we're going to need to take up to the next. So the total for this project is $60,500. Half of that goes to hardware, half of that goes into feeding interns who will be doing most of the programming. So here are some quick details. I'll go through these a little bit quickly. It's about 34 inches by 22 inches with 16-inch height. It's going to have 2 main drive wheels with 4 casters. It's really made to have a low profile so that if you have the production environments, whether you're creating trucks or aviation, that it can get underneath that moving assembly line and clean underneath those tools where that most of that FOD is created, because it's created right where you're working. We'll be using closed brushless motors, and we'll be for all of the mechanical systems controlling the vacuums, the drive wheels, and also the agitators. We're going to steal a lot of the sensor suite concepts from what you see in your Roombas, and that's, you know, the ultrasonic sensors or the IR sensors pointing down to the ground to get distance so that if we hit the ledge or an edge of something, it's immediately known. We're also going to be using those same type of IR or bump sensors or touch sensors to detect when we run into something. That's a last, line of last resort, hopefully, but it's, this amount of safety so that it immediately stops, within tenths of a second, so that no damages contact is minimized. Also, to make sure that the vacuum is functioning, we're going to have some limit switches to make sure that we're always getting good contact and good with the ground. This is a feature that was added to the Roomba that they're able to measure the amount of dirt that's collected and identify that location. Now, since the Roomba doesn't really necessarily create a good map of its space, it's not as useful. But here, because we're going to be creating an accurate map of our space and know exactly where we are in time and space and location, time, space, and location. What we want to know is where are the dirty spots and see if we can't see trends, and then potentially start to change our schedule to make sure that we're going to those dirty spots more often. And this is the big thing that we're going to have to add to this prototype is integrating the LiDAR sensor and building that real-time mapping capability. And the other sensor suite that we're going to have to start to play with that we haven't played with yet is that auto detect for how we're going to make sure that we dock with that charging station and make sure that all the systems are connected and get all those connections worked out. So the FOD BOT project steps are fabricate the chassis, and that's pretty simple. Fabricate the charging station. It's not too complex. We just have to figure out if we're going to be doing quick charge or if we're going to actually allow the thing to switch battery packs. That's the only complex thing about that. Integration of the vacuum components, not that big of a deal. We'll probably start off with a shop vac and then maybe move up to like a Dyson type integrated vacuum capability. Programming the real-time obstacle avoidance software isn't really that big of a deal. We've done a lot of prototyping on that. You can pretty much find that off the shelf at a lot of places. Programming the mapping software, this is the place where we're going to start to get a lot more complex. So adding that LiDAR sensor, getting the real-time mapping capability, and then creating those patterns for how we're going to break down, identifying the space, breaking it down into sections, and then creating that vacuuming schedule and the vacuuming paths automatically within the robot. That's going to be the complex part. And then the last one is actually a little bit harder than you might think, is testing the prototype in a scaled environment. So getting a big open space with large, tall walls relative to the flat space, and then having the robot create that map. So that we've got some options for where we might do that, but hopefully we don't have to expend any funds on that, but that's going to be something that's a bit of a challenge. This is only the first step. If you guys help us on FOD BOT 1, we might come back to you for FOD BOT 2. Hopefully it'll be a lot easier. The big challenges to add to FOD BOT 2 will be the ability to detect aircraft and detect other obstacles that might that you might not detect when you're indoors. So this is pretty much focusing on a FOD BOT that can vacuum and clean outdoors. And it's things like yards, ramps, runways, taxi areas, maintenance areas, any place where you have, again, that dynamic environment where you might have vehicles operating or things operating, but you still need to get that cleaned. So that's kind of our concept for that, and that's hopefully where we'll be able to go after we get FOD BOT 1 working. A little bit about myself. I'm a program manager currently at the CAT Lab at the University of Maryland. We focus on big data and automotive, I'll say visualization. And my previous experience, my job experience was working at Boeing for about 10 years on all types of different commercial and military aircraft. But my robotics chops have been getting at FIRST Robotics, which I've been doing for the last 4 or 5 years. And I'm currently mentoring a robotics team. And this is a project that I'm going to take on. Some of the students are going to help me a little bit with this, and then the interns are probably be coming from one of the local colleges. As well as a friend of mine who does computer vision will be helping guide us for the mapping component of this. So that's a little bit about me and about the project. I hope that you're interested in this. I am. I think it could potentially turn into a business if we get all the prototypes done right and we can show the proof of concept working and for the right price. So please definitely reach out and fund me. Plus, if you do some of the cool perks we have, tie pin, the robotics cleaner are kind of fun, and I think those are going to be cool little mini projects in and of themselves to create those for you if you guys are interested. So thanks again for your time, for listening. I hope you choose to put some funds into the project, and I hope I get to know you a little bit better if you become part of our team. Thank you very much.